Welcome back to week 6. In video 3, we're going to explore some of the major types of landforms that result from glaciers shaping the landscape. So the first question is, well, how the heck do glaciers how does ice carve out the landscape? Well, the erosion that happens is due to both abrasion and plucking. So we'll talk about both of those in the next slide. And then we get deposition shaping the landscape by debris melting out of the ice. Some of the landforms we'll talk about include those associated with valley or alpine glaciation, things like U-shaped valleys, arêtes, horns, cirques, and moraines. And then continental features like drumlins, roches-moutonnées, eskers, moraines, caiman kettle, and some mega floods that are specific to this area. So erosion, the abrasion that occurs, happens because you have the ice moving from one place to another, so moving from accumulation to ablation, and debris is in the ice. It's not just clean, straight ice. It has rocks and sand and gravel and all sorts of stuff in the ice. And so the debris actually moves the same pattern as the ice does. So it flows down to the base and moves along the bottom of the glacier and then melts out at the very terminus. So as that glacier is flowing, it's also dragging these rocks along the base. So we end up with striations or glacial grooves, chatter marks when a chunk of ice has a boulder stuck in it and it kind of ricochets off the bottom of the glacier, and you get these crescentic gouges that result. So we have these two eroding much smaller chunks of material, but then plucking is what ends up removing the most amount of material and getting those large big boulders in the ice. What happens is in this scenario here, you see this hill side that has a nice smooth side on the left, and then a much steeper drop off on the right. Well, the glacier ice here was moving from left to right, and what happened was, as the glacier ice built up on this side of the glacier, the bedrock, we had an increase in pressure. That increased pressure actually causes the ice to melt at the base of the glacier, so you get water produced. Glacier slides up and over that peak, the water comes with it. On this other side, the downstream or lee side of this uneven surface in the ice, the pressure then decreases, and so we have a decrease in pressure. The water that's over here that filtered into the cracks of the ice of ice and also the cracks of the bedrock freezes, and when it freezes, it expands, breaks apart the bedrock, and then the glacier is still moving, so it can actually, if those chunks are frozen and both to the bed of the glacier and around those chunks of bedrock, it can actually rip out huge chunks from the bottom of the glacier. So these are two ways the ice can actually accumulate and erode, but also we can have landslides from the walls of the valley falling onto the ice to get some of this debris into the ice. So deposition, this is where you have debris melting out of the ice, so we can get these outwash plains, which tend to be braided rivers. We get these caiman kettle topography. You can see all sorts of random debris, water scattered about. And then you get these moraines that build up. So this glacier here at one point extended all the way down to this point and was depositing this moraine at the very end of the glacier. So some of the landforms we see in alpine or valley glaciers, these are all erosional. We get these U-shaped valleys, so once the glacier melts away, we see this U-shaped valley in its place. Where the ice is forming and building up, we get these cirques. Kind of looks like someone took an ice cream scooper and scooped out the mountainside. Where we have several cirques surrounding each other, we can get a horn, a peak sticking up in the middle, and then you get glaciers flowing out from around that horn. And then this ridge line you can see here in between two glaciers, or right here, is called an arête. So it's a bedrock hill, a ridge line in between two glacial valleys. We can also see crevasses that form in the ice when the ice flows over uneven topography or speeds up or slows down. You get these big cracks, and you'll be able to see these in some of the Google Earth images you're going to look at in lab. And then we can get depositional features like moraines. So we can get a terminal or end moraine that is where a glacier ends and melts away, so it just leaves one of these behind. We can get lateral moraines that build up on the edges of the glacier. You can see this debris kind of plastered up against the wall of this U-shaped valley. Our end moraine would be right about here. And then in the ice, we can get what are called lateral or medial moraines. Medial moraines are what are in the middle of a glacier. So two glaciers combine here in this image, and when they combine, the medial moraine is formed right down here from two lateral moraines that meet each other. So you have these stripes in the glacier. And so how do these moraines form? Well, this is the material that's building up at the end of a glacier. We have these recessional moraines that can form. So here's our ice flow. We get the debris melting out. When this glacier is stationary, it's not advancing or retreating, but we get the ice still flowing, we still have debris melting out, we still have accumulation, but our terminus stays in the same spot. So we get a buildup of debris. The glacier retreats, we have it decreasing in volume, but then becomes stationary again. So we still have it kind of retreat, and then it becomes stable. Our accumulation and ablation are equal to each other. We get that build up again. And then we have another period of time where it starts to decrease in volume rapidly, and then it becomes stationary again. This happens with glaciers a lot. They decrease in size, they come to an equilibrium, they decrease again, they come to another equilibrium. They might advance over all of these moraines and rework them into a new end moraine. So you can see lots of change that can happen with glaciers. Some of the continental erosional features that we see are things like roche moutonnées, or whalebacks. You can see two images here with the ice flow across the surface, and then where we would have nice polished bedrock, and then the plucking on the lee side. Polished bedrock, plucking on the lee side. We can have huge glacial grooves that span over huge areas, so basically all of Canada. If you were to dig up the thin soil that exists there, you'll see glacial grooves all over Canada because there was once a huge ice sheet there. And then you can see these U-shaped valleys, rounded hills, U-shaped valley. This is Maine. This is an island in Maine that was eroded by a huge continental glacier. Some depositional features, drumlins, which are argued over if they're depositional or erosional. Might be a combination of both. Here you can see a drumlin. It has a steeper side on the left, and then a lower slope here on the right side, and basically the ice is flowing over the steep side and then kind of tapering out, making a streamlined hill. And here's a whole drumlin field from space. You can also get glacial drift. This is looking straight down onto the land surface. These are little lakes. So glacial drift is just all that stuff melting out of the glacier. It's boulders, it's sand, it's gravel, it's clay, all sorts of stuff. We can also get eskers, which are kind of windy little ridge lines that result from a river that was once flowing in the ice, depositing sediment along its river channel, and then the ice melts away and all we're left with is that debris. And then came topography would be random hills, no organization at all of this glacial debris. Kettles would form where you had ice in this debris that then melted and then left this depression for water to accumulate in. We can get erratics that are boulders that come from a totally different place. You can track that the type of rock that's in that boulder up valley or upstream where that glacier came from. This one here, this bubble rock picture, this rock is very different from what it's sitting on. This is white granite, this is pink granite. This white granite came from 20 miles north of here. So pretty amazing stuff. It can be carried very, very far distances and then melt out of the ice and then just leave it sitting in these very precarious situations. So some other landforms we can get are features left behind by mega floods. So this is some landforms. We see huge ripple marks out in Camas. We see wave cut platforms around Missoula. And you see this scab land in our neck of the woods. And what happened was we had This Cordilleran ice sheet that was covering much of the west side of North America. We had a lake that built up in Missoula. You can see here this kind of yellowish area around Missoula that was dammed by part of this glacier. The glacier periodically over time would either melt away or float, allow water to escape through, and then the glacier would advance again, dam up that outlet, create that lake again, and then it would flush out. So it's happened over and over and over again, draining this huge volume of water through this what's called the channeled scablands in around Spokane and eastern Washington, and then it flowed through the Columbia River Valley, backfilled into the Willamette Valley, and then went out into the ocean. So this created the landscape that we see today, one of the major things. And when we go on our field trip, you guys are going to get to see some of those features. And I believe there might be a group talking about this for their presentation. So I don't want to give too much away. So that's how glaciers shape the landscape. We'll come back and talk about glaciers and climate change.